We're going to go through a similar process again in example 2 here, where we're trying to find what the zeros are of this function f of x equals x to the 4th plus x cubed minus 7x squared minus 9x minus 18. Now remember that zeros, x-intercepts, solutions, all the same thing. So we're really finding, hey, when does x to the 4th plus x cubed minus 7x squared minus 9x minus 18, when does this actually equal 0? Okay. Now, if I look at my equation here, I have 5 terms. There's no way we can factor this by grouping, and none of the other strategies that we know would help us solve this equation. So that's where we have to use our rational root theorem. So possible numerators. List out our possible denominators. And list out all of our possible rational roots. My possible numerators, numbers that multiply to 18, could be 1 and 18, 2 multiplies to 18, so does 3, 4 and 5 don't, but 6 does, 9 does, and 18. Okay, 1 times 18, 2 times 9, 3 times 6. You really don't have to write them in order, but I kind of like to. And then denominators, numbers that multiply to your coefficient here, which is 1. Only options plus or minus 1. So then your possible rational roots are combinations, numerators over denominators. We have 1, 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, and then 18 over 1. Now let's check, and hopefully one of these will be a root. Okay. So we go to our calculator again. Go back to y equals and type our equation in. X to the 4th plus x cubed minus 7x squared minus 9x minus 18. My table's already set to ask, so I go to my table, second table, and let's check some of these. So 1 is not a root. I'm looking for anywhere my y value is 0. -1 doesn't work. 2 doesn't work. -2 doesn't work either, because we get -20. If we do 3, 3 is a root. Good. Okay. I know 3 is a root. So let's do our synthetic division. Where 3 goes in the box. And then my coefficients across the top. I have 1x to the 4th, 1x cubed, -7x squared, -9x, -18. Bring down our first number. 1 times 3 is 3. Add. 4 times 3 is 12. We add down, we get 5. 5 times 3 is 15. Add, we get 6. 6 times 3 is 18. Add, we get 0. Now, if you ever end up with a remainder here, that's your clue. Something went wrong in your division process. All right, so this is my remainder. My 1s, my x's, my x squareds, my x cubed. Gives me x cubed plus 4x squared plus 5x plus 6. Now I need to find a way to solve this equation now. I have 4 terms, but this isn't going to group, because these terms have x squared in common, x plus 4. These guys, the only thing they have in common is 1. we can't factor by grouping. And since I don't know any other strategy to solve this, let's go back to our rational root theorem. We already checked the 1s, we already checked the 2s, we already checked 3. Let's keep going and see if we can find another root. So let's try -3. And -3 also is a root. So we want to use division again. With our x cubed plus 4x squared plus 5x plus 6. Okay, because if -3 is a root for our whole long equation here, that means -3 also has to be a root with what we have here, the x cubed plus 4x squared plus 5x plus 6. So we do our synthetic division again. -3 goes in our box. 1x cubed, 4x squared, 5x, and 6. We bring down our first term, 1 times -3, add down, 1 times -3, add, 2 times -3 is -6, that's 0. So again, remainder, 1's, x's, x squareds, that's x squared plus 1x plus 2 equals 0. This we can solve the rest of the way. All right, so to solve this the rest of the way, that's not going to factor. We don't have any numbers that multiply to 2 and add to 1. I don't want to complete the square because my middle term is odd. I have 1x. So my last bet, quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this simplifies -1 plus or minus 1 minus 8 over 2. And this is -1 plus or minus the square root of -7. Square root of -7 is I square root of 7. Over 2, and we can't simplify any further. So this gives me 2 of my solutions, the plus and the minus option. Then I also found 3 and -3 as our solutions. So my final answer, and according to my fundamental theorem of algebra, since my original degree was 4, I should have 4 solutions. My final answer, I have the 3, the -3, plus the I squared of 7, minus the I squared of 7. That's all 4 solutions, and we are done.